The session shall be chaired by Dr. Chandrika Kaushik, an outstanding scientist and Director General, PC and SI at DRDO. And our esteemed panelists on the stage, Lieutenant General Inderjit Singh, AVSM, VSM, PhD, retired strategic advisor, IdeaForge. Commodore Jaideep Maolankar, retired NewSpace Research and Technologies. Professor Nirat, IIT Delhi. Shri Sajal Prakash, CEO, Accessories Complex, HAL. May I request Dr. Chandrika Kaushik to kindly initiate the session.
I'm indeed very happy to be here to chair this important discussion on innovation and technology development for transparent warfare. The role of technology in shaping the modern warfare has never been more pronounced than it is today. In today's dynamic geopolitical environment, as is visible both on our northern side as well as in the Middle East, we have all witnessed how battlefield transparency can redefine the nature of combat. Real-time intelligence, precision tracking, situational awareness have enabled countries to counter conventionally stronger adversaries. By leveraging the technologies of unmanned vehicles, commercial satellites, advanced ISR platforms. This underlines a critical truth. Those who dominate the information battlefield gain a decisive edge. We need to look at where we are in the current scheme of things from a technology perspective, processes perspective, and in the implementation framework, how do we enable the systems to bring in superiority in this domain. Space-based surveillance systems like electro-optic infrared satellites, synthetic aperture radar, constellations are today able to provide a near real-time, persistent global situational awareness in the areas of our interests. The US's Starlink, China's Yaogan, in addition to the Beidou and all, we are all aware of the capability that they bring to the armed forces. Innovations in quantum and advanced radar systems are reshaping the detection capabilities. The quantum radars that are coming to the armed forces they're almost there. How will this impact the battlefield scenario? The proliferation of persistent UAVs and HAPS platforms is another game changer. Coupled with artificial intelligence and machine learning-based predictive analysis, with edge computing, these platforms are now capable of rapid data to decision cycles. AI-driven systems are also enabling the anti-jamming secure communications, real-time analytics, and these are becoming essential tools to counter the adversarial advances in transparency. With transparency comes the challenge of overexposure. Excessive reliance on ISR systems also lead to a challenge of cyber attacks. Counter surveillance measures. We need to have counters to the excessive intrusion capabilities also. We need to look at how do we create operational ambiguity, how do we disrupt the adversarial transparency efforts, and enhance survivability in contested environment. Maintaining a delicate balance between the visibility and security will be critical for all future operations. For us, the way forward is in accelerated innovations through collaborations and preparedness. We must rapidly expand the EOIR, SARC satellite constellations, the hyperspectral imaging capabilities, advanced radars, quantum sensing systems. Developing robust UAV and HAPS networks for persistent ISR to enable near real-time situational awareness is not a luxury. It is imperative in the forces. How do we make this happen? The way forward is to foster user academia industry collaborations. We need to look at unified funding policy, multi-stakeholder participation in programs of national importance. Partnership with the startups will accelerate technological development. We have a lot of innovations going around in the ecosystem. How do we leverage them and bring them into the mainstream to develop operational capability? Some of the successful model like the France Aerospace Valley and Silicon Saxo from Germany have shown how collaboration can boost industrial patents and research outcomes. And converting this intellectual capability towards operational capability is what will determine the success or otherwise for us in our battle preparedness. To build a self-reliant defense ecosystem, we must strengthen local supply chains, cultivate a highly skilled talent pool. And there is no dearth of talent in the country, but we have all experienced that the outsiders are better at harnessing the talent pool that is existing in the country than us. How do we reverse this? How do we promote knowledge sharing across research institutions and industries? A whole of nation approach will be vital in integrating the national space strategies, defense policies, cross-stakeholder collaboration. By doing so, we can ensure resilience, speed, and innovation in our technology pipelines and reducing the development timelines. The future of warfare will be determined by the transparency of the battlefield that is available to the soldier in the battlefield. The lessons from the ongoing conflicts are clear. Information superiority, technological innovation will determine the success. And transparent warfare is not just about seeing first and better, but also about deciding faster and the ability to act decisively based on this information. I'm very happy to have a very, very distinguished panel with me. We have Lieutenant General Inderjit Singh, who is the strategic advisor, IdeaForge, who's going to tell us about FPV drones in transparent warfare. Commodore Jaideep Maolankar with NewSpace Research and Technologies, who's speaking on the Nextgen collaborative autonomous warfare. Professor Suresh Neelakantan and Professor Nirat.
Suresh is not here.
Okay. Professor Nirat Ray from IIT Delhi, who will be talking about ultra-thin, high-entropy, alloy-based metamaterials and metasurfaces for multispectral stealth. Mr. Sajal Prakash, who is the CEO of Accessories Complex HAL, who will talk about aerospace technologies for transparent warfare. Look forward to an insightful and engaging discussion from the esteemed panelists on the dais today. Over to you, General Inderjit, for your talk.
Thank you very much, Dr. Kaushik. And it's a pleasure to have you chairing the session. And ladies and gentlemen, good afternoon to all of you. We have 10 minutes. I'll try and cover my subject, FPVs, which is first-person view drones in transparent warfare. I'm sure most of us would have heard about these, the way they've changed the dynamics of war, the ongoing conflict between Russia and Ukraine. And there are a large number of lessons to be learned. I'm going to talk about a few things. Now, the scope of my presentation basically is, let me just share with you what I feel is the impact of the FPV drones on the concept of transparent warfare, followed by key technologies which are enabling such drones, What are the technical challenges? We have limitations on these drones. How do we overcome these limitations? And then, how are these drones, how are they going to actually enhance situational awareness and decision-making in the Indian Army? The operations both in the CICT as well as in conventional warfare. Right, going on to the first part, which is the impact. Certainly, there's enhanced situational awareness. As you know, these drones provide real-time surveillance, video feeds to the operators, in the battlefield. Now, this is something very, very new. And they can then guide precision, they can guide teams onto the targets, they can guide other munitions on the target. So it's become a game changer, in fact, what the recent conflict tells us. They are highly cost-effective precision strikes. Now, they've changed the dynamics of warfare. If you look at it, very low-cost option, but from going for a high-intensity, high, investment war, we have gone to low investment in very large numbers. And the effect is tremendous. We find these drones provide great agility and flexibility. They are highly maneuverable, and they can operate in various types of terrain and environmental conditions. The agility is actually then by the soldiers and the teams ahead can be put into a battle-winning factor. We go on to disruption of traditional warfare. I just talked about very briefly. Conventional military strategies. We are now shifting the focus from high-intensity, high-investment wars to more targeted and asymmetric warfare. And this is something which I think is something we all, at least from the armies and the point of view, we are learning a lesson, and we are now getting it in our operational doctrine. It's still a little far away, but there's a lot of study being done in this field. Innovative tactics and countermeasures, yes. As you study warfare in use of drones, we find that it's a cat and mouse game, which is happening all the time. There are measures, countermeasures, which are evolving. And with the result we find today, the whole drone technology has gone a paradigm shift, thanks to the MPVs, largely. We're not talking about hail, we're not talking about male categories. We are looking at battlefield, actually, right there on the spot. Civilian involvement, for the first time we find, the lines are blurred between the civilians who actually gone to the, aid of the soldiers, and they started picking up any drone, commercial drone, and they've actually made them into munitions, and very, very effectively. And this is whatever lessons we are learning from this Ukraine. Maybe may not be very relevant to us today, but you never know what happens in the future. Right. Some of the key technologies which are enabling these drones are basically advanced cameras and video transmission systems. We know about this. Agility and maneuverability. Now, these drones can go in, they're very agile. You can maneuver them, you can take them to the point of action and guide them so that they give you real-time video feeds. And when they are going in the next role of kamikaze capabilities, you find that they are a potent weapon, whether against tanks, artillery positions. In fact, certainly the world realized, and in fact, recently, Elon Musk has given a statement. Do we really need F-32, F-35s? Why can't we do it with drones? Now, you can imagine how the thinking is actually changing with this drone warfare. And if you ask me, frankly, I think drones have become a weapon of war. There's a revolutionary in military affairs as far as drones are concerned. And we in India also, I think we are in the process of learning our lessons. We have a long way to go. I won't say that we have all the technologies. Okay, cost effectiveness. Definitely low cost, large numbers. And this is where you find the military budgets. We are always constrained by budgets. Here is a low cost option. Your budgets don't run out. In fact, I was just reading a little while back, Ukraine has actually set a target of making 1 million drones a year. Now, it's an unheard of figure, actually. We, in the Indian Army, we just about got 1,000 drones which are inducted. Of course, they are high-end ISR drones. We are getting into logistic drones. But 1 million drones, I mean, they're losing at the rate of 1,000, 2,000 a day. That's the level of, operational capability they've brought to bear. Right. Now, going on to the technical challenges, definitely the signal interference and jamming, because, countermeasures, we find these drones being very low cost. They don't have the ability at this point of time, largely. They're prone to hacking. Spoofing is not really required in this case because they're too low cost, but definitely hacking and jamming. They have limited range and endurance. They have a limited range, maximum 5 to 10 kilometers. The endurance is not more than 30 minutes, but they do the job. There's a quick turnaround. So what these combat teams are doing, they have, power batteries. They replace them quickly and send the drone back into operation. And there are, literally tens and hundreds of missions taking place with the same drones. Right. Environmental and physical obstacles, certainly. They are not that hardened drones under difficult environmental conditions and physical obstacles in dense warfare, dense jungles, urban warfare. They have, some disadvantages, but now actually, as technology is getting better, which I'll share with you, many of these things are in the process of being overcome. Vulnerability to physical countermeasures, yes, you now each, like I said, is a cat and mouse game. So the armies are literally finding all sorts of methodologies. You have General Saxena here on the counter drone systems. You are from Zen, and you will find even at the lower level, they're using drone nets. They're using other drones to shoot down drones. So, but having said that, they are proving the worth in a very, very significant way. Security risks, yes. They're prone to hacking. So if there's any video feed coming on, that can very well be hacked. And a lot of security risks are then in the offing. So this has to be kept in mind. Right. Now, some of the limitations, limited payload, they're small drones. There's short range and endurance, I talked about it. Definitely very vulnerable to electronic warfare. Operational complexities there. Now, what happens is to fly these drones is not easy. The operator has to be very, very, real-time maneuvering, because he'll get no value out of the drones. If he's got to use it as a kamikaze drone, he's got to be hovering just at the right time before the drone is shot down, before he can create a kill. We have certain lethal and ethical concerns. Now, this is not being talked about much in the kind of warfare which is going on at this point of time in Ukraine, where they're largely being used, a little bit in Israel, not too much really. But there's certainly a lot of ethical concerns which we have to factor in when we get these drones in larger numbers into our forces. And environmental limitations I talked about briefly. They need to be battle hardened. They need to be environmental hardened. Right, so some of the limitations, how do we do it through technology? At the end of the day, the chair talked about technology. It's all about technology. How can we make a better product at a lower cost? How do we optimize? And we are getting there now. Definitely, we are using much better increased materials and modular designs. Better materials, advanced materials, lighter, which allows heavier payloads to be lifted. When you talk about modular designs, it enables these drones to quickly switch from one payload to another. Now, that gives a lot of versatility to these drones. You look at extended range and endurance, we have a huge now better battery technologies, whether it's solid-state batteries, we are looking at fuel cells, we are looking at hybrid propulsion systems to increase the range and give it more endurance. And some areas, in fact, I think many of our own companies in India, they're working in this area. We got NewSpace sitting here with me, one of my colleagues, and I'm sure I brought a smile on his face. We're all working there. I think we're all actually trying to, go into this area, which I won't say, and the chair made a very nice, apt statement, and I really laud her for that. He says we have the capability, we are not using it. I couldn't agree with her more. Today, we have thousands and thousands of GCCs for every MNC you can think of in this country, using our talent. And what are we doing? How many of our Indian companies have GCCs? Very few. We are not very sure how to leverage our own capability and technology. So what do? They get the license and we keep paying for the license. I mean, this is not a very healthy situation, but I hope with the kind of efforts now DRDO is also putting in, and they're inviting a lot of private vendors, I'm sure we'll do much better. Improved autonomy. Now what happens, I mentioned a little while back that any human error, this drone goes kaput. So we are looking at greater autonomy, but better using more AI systems, more machine learning, so that you certainly at the end of the day, you're able to have higher degree of effectiveness of these drones. Cost-effective maintenance and production. I think you're all aware of it. You're looking at modular components, 3D printing. You're looking at predictive maintenance. So even before the failure takes place, you are able to predict failures. You do renewals of the equipment, get much better life out of the equipment. Environmental adaptability. You're looking at weather-resistant designs. In fact, even my company, we have gone way ahead now in this field. Whether operating in higher altitudes, we're looking at dual use. We are looking at all-weather drones. They are the need of the hour today. I mean, we talked about SARS. The chair talked about SARS. That's another capability you need immediately. To look through clouds or through fog, and advanced sensors. The SARS and all these sensors are a part of that. Right, autonomous, interoperable systems. So, in fact, I've covered this. The last point is record keeping. Yes, now, we may get any amount of feed. Unless we can integrate that feed, use it in real time, use AI, and make decisions in time. Again, the decisions which are not in time are no decisions at all. We all know this. But I think all of this through cloud, we are getting there. But this is definitely a need in terms of technological development in drones. Right, as far as enhancing, the last point, enhancing situational awareness and decision making, Indian Army's operations, all the factors I talked about, they're all relevant to us. Whether we are fighting CI/CD ops, whether we are going to fight a conventional warfare tomorrow, whether we are doing border management. Ultimately the commander is only concerned with 5 kilometers ahead of his defenses. That is where the real action takes place for him. And if he can get that kind of feed, real-time feed, and if he can take action through technologically improved drones, if we can have those kind of, they are like loitering ammunitions, these drones, at a very, very small scale. I think those are all battle-winning factors. I've finished. Thank you very much.
Thank you, General Inderjit. That was a wonderful elucidation of the first-person view drones and how do we actually bring them into the battlefield scenario. May I now request Commodore Maolankar to deliver a talk on the Next-Gen Collaborative Autonomous Warfare. And I apologize for not introducing the speakers, but I think all of you know the so I kind of skipped that part. Please go ahead.
So it's probably a good time to use that old joke. How do you know who's the fighter pilot in the room? He'll come and tell you who it is, right? Anyway, good afternoon, gentlemen. Welcome to the graveyard session. I can see that we've successfully driven away most of the people who were wise enough to escape. Unfortunately, the real audience I wanted to sink my teeth into are missing. I'm hoping that this talk will find its way onto YouTube and get some suitable traction. So the talk might sound a bit professorial because paucity of time, the kind of topic too broad. But I think it's important to keep things simple, to get a simple message across, because I think there is a lot of different interpretations. I'm being polite. A lot of different interpretations, and largely there is a bit of an irony in talking about disruption in an audience which primarily consists of the people who are going to be disrupted. It's easy to talk about revolution in military affairs, after a sumptuous lunch. So there is an essential contradiction which therefore needs some very basic straight talking. I'll split it up into the 3 words, basically like a college class on definitions. Next gen. What is next gen? You can't talk about it unless you say what is the previous gen, who is going to be disrupted. So the previous gen one can classify as ever more exquisite, ever more expensive platforms in fewer numbers. All of us here are actually part of this generation of who can only think and only really understand exquisite platforms. It reflects clearly in the way in which we write our requirements. For example, we circulate a file, it accumulates like we say rolling stone gathers no moss, but our files gather requirements as they run through the various directorates. Basically, there is no engineering which does rationalization of all these various requirements to make it into a buildable spec. The result of it is that these weapons take 15 years to build. When they get built, they are always short of what were the listed requirements. We call them failures, but actually they still do a pretty decent job of what they were supposed to be doing. What has changed is what we are expecting them to do, not whether they do what they were supposed to do. Nevertheless, the problem is that they remain inherently brittle. They're typically reliant for their superiority on one specific technology, which can easily be overcome by. I mean, everybody expects that clearly does not expect stealth to last forever. At least RF stealth against the mid to high frequencies. I'm sure you don't expect it to last forever. So they are inherently brittle. Once that gets unmasked, you'll suddenly realize that an F-35 is less maneuverable than an F-16. I'd rather be in an F-16 than be an F-35 if the stealth has been defeated. The problem with them becoming more and more exquisite as they become more expensive. When they become more expensive, you buy fewer. Because you buy fewer, they have to become even more exquisite. So the problem is that the actual numbers that you need is completely unaffordable. And unaffordable is not just a matter of the initial acquisition cost. I'm talking about life cycle cost. I'm talking about attrition, replacements. I'm also talking about your willingness to risk them because the platform itself becomes too valuable. So we had all these discussions about Mirage 2000 can't be used for closer support, etc., etc. Net result, Kargil war had only 8 LGBs being authorized for use against it, while that video shows us exactly how effective it could really have been. So basically what I'm trying to say is exquisite platforms, they lead to an unwillingness to commit them and almost avoidance of combat. It's a very harsh word to use if you interpret it as in terms of courage. I'm talking about in terms of resource allocation versus cost benefit kind of thing. So basically these platforms become operationally unusable. If that is the previous gen, then what is the next gen? It has to be pretty much the opposite, very large numbers. You can't have very large numbers of dumb things because you won't be able to control them, so they have to be very smart things. If they're very smart, they can do very dangerous things, and therefore you need to have humans in the loop. Those humans have to be few. You have to give them the means to be able to control these large number of, it's actually collaborative robotics, not swarms, which is the word I like to use. But basically when you bring imagine having a PhD as a sniper. The quality of sniping is definitely going to be of a much higher quality than having a farm boy being trained just in the trigger action of how to operate a sniper rifle. So I'm talking about that class of human being brought into collective robotic systems, and obviously it will change and disrupt our HR and our whole concepts about specialization, promotion, promotability, etc. Completely. All of this is what will allow us to bring back the principle of mass into warfare. Now, all of this is cheap talk unless you turn it into engineering principles and start building things to match up to these lofty claims. So just a simple interpretation. A lot of these slides are busy. They're meant for you to look at them, study them in detail, because I spent a fair bit of time building them up. There's a lot of thought gone into each of the words. So when you say large numbers, when you say mass, it's not just a question of the affordability in terms of how many can you afford to buy the first time. It's also how many can you afford to stock. That means is the design sustainable for proliferation? Can it withstand supply chain disruptions? Can you scale it up in the course of a conflict? All of those elements have to come into design. That means designing for production, which we discovered as a revelation during the LCA journey, that we hadn't designed it for production, for producibility. All of those things need to be learned on, imagine them magnified 10x. Smart, unfortunately, the word smart got used up prematurely by business development guys calling precision weapons as smart weapons. Those are not smart. Those are pretty much dumb weapons. Capable of doing one task very well. They were not intelligent. They were not learning weapons. This is a class of weapon which we are going to have to train, almost like your own wingman. We use the term loyal wingman, evoking images of him flying next to you. Actually, what you mean is the guy whom you have trained, and the advantage of scalability, that the training that you invest in one platform immediately translates across the whole fleet, unlike a human wingman who keeps it to himself and uses it to claim superiority in the crew room. The human element, on the one hand, we hear customers looking at it purely as a way of replacing human and solving their HR problem. It's not a way of solving your HR problem. It's going to change your HR problem from fairly simplistic mass recruits for a meat grinder, turn it into people who can understand and actually operate and actually wield a weapon. Wielding a weapon is different from is a higher order of training than even operating a weapon, and therefore you need to have a reduced human element, but that human element has to be of a much higher quality, which is capable of teaming, which is capable of handling terms like collaborative autonomy. Full autonomy is something which, frankly, I think is a pipe dream for a long, long time because of the nature of warfare. Not because autonomy technologies don't exist, but because the nature of warfare is such that every time one side gets an overwhelming superiority over the other side, the underdog is going to change the rules of warfare and basically negate that technology and change it into something else. And therefore, full autonomy will never actually develop. And largely is the use of mass. And by that I don't mean just a mass, which is just engaging in a melee, but I mean something which results, which has a large number of objects collaborating in really vicious, wicked ways in order to create some really high-end capabilities. So we need to have the term collaborative, cooperative robotics rather than just swarm, because swarm is another word that is buzzword that is misused very heavily. Next word, autonomy. I'll try and go fast. This is a busy slide, again, a lot of detail in it. But if you see at the center of it, there is a human. Why have I chosen to put a human right in the center of an autonomy slide? Because autonomy is not a binary. It's not a binary word. If you see at the left, it's an attempt to define autonomous capabilities that we want for every stage of the operation. So whether the stage is in the phases of the operation or the stage is in the part of the cycle, which part of the UDA cycle are we really addressing? That's why it's a table of which phase and whether you're addressing the O or the D or the A part of it. A lot of detail, which basically means it's a highly granular definition. It is highly subjective. What do you really want? The actual technology, the actual algorithm that is in there, you might not even call it AI, frankly. You might just even call it a simple algorithm. You might not even give it the fancy term of automation. It might just be a simple calculator. But it could do wonders when it is framed together in this kind of a framework, which allows you to apply technology selectively to the operational concept, to the doctrine, to the way you want to fight. And that is really what is captured by those two tables on the left. I've already mentioned the term UDA. Again, it's a term that is really grossly misused, particularly in the armed forces. I think DSSC is the greatest perpetrator of this crime. I think UDA needs to be studied in far, far greater detail. Everybody talks of UDA cycle, speeding it up faster and faster. Actually, it's not. It's a much, much more subtle. It's a much richer concept. I would really refer you to listen to the original lectures of Boyd. He was a savant, and if you truly understand that is when you will understand what is the complexity involved in implementing autonomy, because you're trying to replicate human-like capabilities, human-like processes into these kind of robotic weapons. Then comes the thing about multi-robot doctrine. When I want to operate multiple robots, a lot of us we think of unmanned objects as remotely operated vehicles. Actually speaking, we want to bring in mass. My previous slides, and therefore you have to think in terms of multi-robot doctrines. All the technologies associated with that. It's not just it's not just anti-collision. It's not just mesh networking, but it's also how do they vote? What kind of algorithms do they use in order to allocate tasks amongst themselves? The fact that we're going to have to operate across a bandwidth throttle, and therefore you can't have video, streaming back to thing. In fact, that's the silliest way. It's like having a compound eye. You need to finally, war is fought by one brain. You can have 1,000 cameras, but they finally need to be fused into one brain in order for a smart strategy or smart tactics to result in some kind of victory. And therefore, they need to be turned into data. Once they get turned into data is when it is appreciable by one brain, which can then outsmart the opponent. And that is largely because of the bandwidth and the fusion into a common orientation, the O part of the UDA, which is really important. And that's what really puts it together, which allows you to think in terms of why do I need to have autonomy? It's because I want to implement all of these things through one brain commanding all of these kind of things. I've purposely put the swarming thing at the bottom because actually it needs to be simplified. Actually, it's swarming tactics. The Mongols used swarming thousands of years back. It's not something new. It is those kind of tactics that we need to implement with multiple robots now, rather than with humans. That's really the correct place to frame the correct framework to talk of the word swarming. And the last in the bottom right corner is these two catchphrases which everybody throws at OEMs or startups like a weapon that I want LOI 5, as if that is the greatest thing since sliced bread. You will not want LOA 5. You will not want LOI 5. What you really want is a correct blend, the appropriate optimum blend of LOI and LOA, that is levels of interoperability, interaction, levels of interaction and levels of autonomy that need to interact. That is what is captured by that table on the left, which is in all its subtlety and all its glory. Therefore, unless you understand it this way, you will misuse this word of autonomy. And the last word is collaboration. So basically, I think I've made the case fairly rapidly for using a large number of robots. So those large number of robots can't be used unless you have a large number of humans individually operating them, in which case they're just a uncoordinated mass. But if you want them to operate like an intelligent, sentient being, then they have to collaborate. The logic train is what is captured on the slide. Because the exquisite is unaffordable, you need to compensate with mass. Because you have to compensate with mass and keep it affordable, that mass has to consist of subscale objects. It has to consist of fractionated capabilities, because even when, for example, two Rafales, which are capable of doing every part of the mission, when they are taking part in some specific tactic, each Rafale is basically doing one role at a time. It could easily have been replaced with an aircraft which is capable of doing only that role. There are some very interesting comparisons of multi-role, single-role fighters. 2008 RAND study of air combat, past, present, and future. Very interesting games. I discovered this thing of called Colonel Blotto games. Basically pitting a force of F-22s which have a probability of kill of 1. That means everything they shoot gets a target, versus a force, outnumbering force of Su-30s, Su-27s, who have a probability of kill of 0. That means whatever they shoot has no chance of hitting, and still red wins every time. It is a surprising result. It needs to be studied in great detail. I really wish our higher military education syllabi, veer towards these kind of things. These are all from US Navy postgraduate school papers. Great reference source. I wish our academy institutions also start producing research of this quality. That is what is something to be studied. Of course, there are the traditional imperatives for the unmanned, dull, dirty, dangerous, etc. But there is also, where it was upon the unaffordable life cycle costs, the fact of the manpower costs that are needed with manned systems, and therefore you need to have the mass to be unmanned if you want mass. That's basically the whole thing that it puts together. So we're really talking about collaboration being driven by the fact that you want an affordable unmanned mass, which is going to be possible only if we address each word of it. Affordable will only be if you have modest unmanned capabilities, which obviously needs to be compensated with a few but higher quality humans. Those few humans should be allocated task of commanding and not controlling operations. LOI 1, LOA, whatever it need be, so that the human can play a chess game and not be have to sit and learn commands. Command X and Control V is doing what. All of this, as far as the customer is concerned, the one message you should take away is there has to be deep understanding, which will result in extreme discipline in framing of requirements. The discipline of requirements engineering, and here I mean the science of requirements engineering, is something that we don't teach. Anybody? We don't teach systems engineering, we don't teach design, but requirements engineering part of the systems engineering is something which the greatest damage is done at that stage of it. Just to give you a stark illustrative example of this, we do our PDR before a project is sanctioned. It basically means the key ideas that are going to make that project a success are done unfunded. They are done by big borrowing, stealing from other resources. It is no wonder that our projects run into trouble when they actually get built. There is a graphic at the end of it. You can see this. You can click it through. I'm just doing it so that it shows up on the video, which will kind of explain this whole thing properly. Thank you, gentlemen.
Thank you, Commodore. Very interesting and very plain talking. Thank you. And now I request Professor Nirat Ray for delivering her talk on the metamaterials and metasurfaces for multispectral stealth.
Very good afternoon, everyone. Thank you, ma'am, for the introduction, and quick shout out to the organizers for having me here. The perspective that I'm here to offer is going to be a little different than what's been talked about, because like in her introduction, ma'am had mentioned that, to make anything successful, you need a collaboration between user, academia, and industry. So I think of myself as sort of a representative from the academia angle. So I'm going to talk about something new that we've been working on, something new that people have been working on, just to give you a perspective of, I won't make the mistake of calling it Nextgen, but let's just say that it's what's hot in the market right now. Okay, so once again, since I do represent academia, I really can't help but, there's always the teach in the teacher. It's hard to drive it out. So I'm going to start with a bit of a general introduction to what metamaterials are. So for those of you who are familiar, it'll be a refresher course, otherwise it's new information. So essentially, different types of materials exist in nature, but sometimes we can go ahead and make structures. So artificial structures, man-made structures, if you will. And when we make these kind of structures, they have properties which basically do not occur naturally. So these are what are known as metamaterials. And just like all materials are made of atoms, if you are making a metamaterial, you're going to make it with meta-atoms. So the meta-atoms tend to be the repeating units. So a lot of things, a lot of fun things you can do with these materials. You can make negative refractive index materials. You can make super lengths. Essentially, these kind of materials, when used optically, can give you cloaks of invisibility. And of course, more recently, people have used these to make what are known as perfect absorbers. So it'd be something that you could completely cloak yourself in. In the big picture, of course, we only realized it experimentally at a very, very small scale. So this slide shows you an overview of what metamaterials can do. So you can see there are sort of 4 different directions. You can have mechanical metamaterials, thermal, acoustic, but what I'm going to be focusing on are electromagnetic metamaterials. So these are what you would encounter in the case of stealth applications. So you could look at making electromagnetic cloaks. You could make at looking electromagnetic absorbers. And of course, you can do this in different frequency ranges, including the terahertz ranges. So if you look at the history of stealth technologies, starting from way back in the 1933 to all the way up to 2007, different classes of materials have been used. And in 2016 is when a sort of new class of materials was introduced. And this is really a burgeoning field. So if you look at this schematic over here, I'm just going to try and pull up my pointer. So, research in this field has really spiked. It's almost like an exponential increase. You see this is in 2024, and way back in 2000, it was almost a constant thing, right? So there's a lot of interest, even from academia, into developing materials for stealth application. So different classes of materials, of course, have been looked at. I have tried to put together pros and cons. So I'm dividing my attention into 4 basic categories. So you have your polymer based, which is very light, flexible, works very well. Only thing is there's the issue of degradation, and of course their conductivity is low. So depending on the kind of application, they may not always work. People use ferrites. which essentially have some form of magnetic elements. They have very good magnetic properties, so they can do certain things very nicely, but they're usually very bulky and brittle, so again, don't work. You have carbon-based materials, good environment friendly, very stable, but have certain mechanical limitations. Then, of course, you have your classic metals that we use, high conductivity, but pure metals, as you know, can be very, very expensive. And of course, you have to wonder about the corrosion resistance of these materials. So in this context, and this is what my graph was trying to show, in 2016, for the first time, people started to look at alloys. So rather than using just one element, you take a mixture of elements and then try to improve their properties. So it came about as a new class of materials for stealth. I'll apologize for the problem with the display. I don't know what's the issue, probably a version mismatch. So essentially, what alloys give us is you can have lightweight alloys, even if your constituent elements are heavy. You can have flexibility, you can have ductility, you can tailor them to have dielectric and magnetic losses as something that are very relevant. And they're pretty easy to manufacture. I don't really have to worry so much about the purity of alloys. I kind of just blend everything together and we can make up a nice mixture. So a new class of a special class of alloys that have been used for materials for stealth applications, in particular EMI shielding, are what are known as high entropy alloys. So not to go into too much detail, but high entropy alloys basically take elements in equal proportion, so equal stoichiometry, and mix them together. And they're usually a large number of elements that go into the alloy. So they're not just one or two elements. Almost always that number is going to be greater than 5. And you can pick and choose which metal you want to put into the alloy depending on what kind of property you want. So you can, let's say, enhance the corrosion resistance by taking out one element and replace it by the other. If, let's say, you are building something for naval applications and you want something to be resistant to salt water, you can take out one of the elements and just replace it with an element which has shown better resistance to salt water, as an example. So this allows you to tailor the stealth properties of these materials, and some amount of work has been done in literature. Again, these are all very, very recent things. So if you look at what these things can do, I'll take your attention to this column over here. So they show pretty high reflection losses, about minus 47 dB and so on, for each of these compositions that have been weighted. All right. So what we've been working on is, rather than using, if you look at the thicknesses that people typically use, they're in millimeters, sometimes thicker. So to basically create even these kind of thicknesses, it's not always easy. So what we've been working towards is, there used to be a lot of hype around nano. So we basically said that let's go and take one of these materials and take it down as much as we can. So there are two advantages when you do this. If you take down the thickness of a material, there's a lot less weight that goes in, right? If weight was a constraint, and you can still retain all of those mechanical properties. At ultra low thicknesses, you can also retain optical transparency, so that's another point. And the kind of composition that we worked with, we basically found a material which can do both, and that's sort of a very rare thing. So you worry about two aspects. One is you want to shield your thing from any kind of electromagnetic interference. You want to stop things from going in, so kind of like creating a Faraday cage. And the other thing that you want to do is you sometimes also want to avoid radar detection, right? So there we talk about a reflection loss, which means if something is coming in, how much of it goes back, and then do you get detected or not? So normally, these two kind of applications go opposite to each other. So if one material, if it does one thing, it will not do the other thing. But by tuning the composition and the thickness, we've basically come up with a material which can do both. Not very, very well. You see the numbers here are not minus 50 dB, but you have to keep in mind that the thicknesses that we are using are only 50 nanometers as opposed to millimeters, right? So 6 orders of magnitude decrease in thickness, but only about a factor of 5 decrease in the reflection loss. And just to give you some perspective on the numbers, typically, if you look at the standards, anything below 10 dB is considered as probably works, right? So this is a work in progress, and of course, more user, academia, industry interaction is required to modify the process and also scale it up. So since my talk was about multispectral stealth, so I'm going to quickly touch on that as well. What do I mean by multispectral stealth? So essentially, with all of these advanced detection techniques, people are now looking at stealth across different things, right? So you want stealth in the visible region, which sometimes people use camouflage techniques to get. You also need stealth in the infrared region, so you have these complicated EO/IR detectors where people can just pick up your infrared signatures and take it from there. And then, of course, you have the radar. So as materials advance and our knowledge of how to use these materials advance, ideally you'd like a solution for the entire thing. So a coat or a protective layer that you put on, which works in all of these three domains. And that's sort of how we define multispectral stealth. So in this, like I said, you can actually structure things, and this is where meta surfaces come in, and this is something that we've also been looking at. So the material, of course, composition and everything you can decide, and that's something that you can tune also. But then you can take these materials and you can sort of pattern them, right? So you can create a composite structure which consists of essentially 3 layers, if you will, although the 3 layers may never be that discrete. So the 3 layers that we envision are the following. You're going to have an infrared shielding layer, a radar absorbing layer, and of course a dielectric spacer that gives you the optical transparency or the optical camouflage effect. So the way to achieve it is actually you can still achieve it with the same material. All you have to do is use some of the existing patterning techniques that are very well known in the semiconductor industry. So if you pattern these films something like this, you can actually make filters out of these patterns. So you can make low pass and high pass filters, and once you use these filters, you can create patch arrays. So the patch arrays, what they're going to do is they're going to allow one type of frequency to go through, but the other type of frequency is not going to be able to come out. So they're sort of designed to give you multispectral stealth without any extra interventions. It's just that you have to work out a little bit on the kind of frequencies that you want, and then you have to optimize the design a little bit. So I'm going to show you one example again from literature. This is also pretty recent, published about a year back. So here, coincidentally, people have used high entropy alloy ribbons, and they've patterned the ribbons to create these kind of frequency selective surfaces. And based on what kind of frequency the surface is selecting, you sort of see the reflection loss or the microwave absorbing frequency kind of shift back and forth. So it's these kind of optimizations that one can do with the material that you work with to give you multispectral stealth. So with that, I'm just going to quickly conclude. The idea for today's presentation was to give you a very brief overview of where stealth technologies are headed, and this is something that people can look forward to. There are lots of innovations going on with metamaterials to be able to give you ultra-thin, lightweight, and flexible designs with enhanced durability and environmental stability. We believe that high-entropy alloys are a new class of materials that could really help drive innovations in this field. And of course, the future direction is as always. So thank you so much for your time.
Thank you, Professor Ray. Very insightful. We'll come to the discussions later and request for comments from the audience also. A request Shri Sajal Prakash, CEO Accessories Complex HAL, to deliver his talk on technologies, aerospace technologies for transparent warfare.
Good afternoon, Madam Kaushik and distinguished panelists on the dais. Dr. R.K. Tyagi, former chairman and my mentor. Lieutenant General Lama, former Vice Chief of Army. Madam Joshi, former Secretary Defense Finance. And distinguished audience present here. First of all, let me thank the Society for Aerospace, Maritime and Defense Studies for giving me an opportunity to come and present in front of you my ideas. The topic given to me is aerospace technologies for transparent warfare. So since morning we've been discussing transparent warfare, and I think every one of us now understand what transparent is about the warfare. And what I have understood is, so far the developed countries were deciding what kind of warfare will happen. And probably this time, in the last few years, this disruption has happened. And the countries who have been in war, they have decided what kind of technologies they are going to use. So now we are learning from what has happened in the recent wars. And the reason for that, as during the panel discussion of Secretary Defense Production and Director DRDO, we were told mostly the research used to emanate from military. And now the time has come when it is going back from civil. So, and that's a very, very big disruption, I would call, because the military, the numbers are few for innovation and disruption, whereas a technology, when it is handled by a civil community, the opportunities are enormous, and that is what we are seeing these days happening in front of us. And believe me, tomorrow's warfare are going to be much, much more disruptive. And that is why I compliment the society for having taken the initiative for organizing this deliberation on transparent warfare. I'm sure that not many countries would have done this kind of discussion so far. So thank you very much, sir, for taking this initiative. I've been asked to speak about aerospace technologies for transparent warfare. So technology in today's perspective, they are not limited to any specific branch of engineering. In whatever kind of digital revolution we have, and whatever, in fact, the digital technology, what we are seeing in commercial segment has found its way very effectively to all the military applications. So terming this as an aerospace technology, in my opinion, will not be correct. But anyway, I would discuss on certain specific things which so far conventionally we have been using in aerospace. And I feel that will be very pertinent if we can deliberate a little bit more on this and see how our country can take these things in mind while deciding the course of action for the future research and technology in this country. During the discussion since morning, what has come out very clearly with respect to the transparent warfare is the collaboration. Very, very intensive collaboration. Not only one or two agencies, across the disciplines, across the segments, whether it is academia or the industry, or the government, or the users. So collaborations at every level. So that is something which is going to happen, and that makes the task very, very difficult for the new technologies, rather for the country and for the government to decide the course of action, how we are going to get benefited. When I discuss the technologies in the context of our country, there are two aspects of it. One is, how do we be offensive in times of need? So how do we have the technologies for remote sensing, for deployment of the platforms or the equipment, or mining the information, analyzing the information and deciding our strategy? That is one way. And second, how do we counter ourselves from these things which other countries are going to do on us? So far we have been lucky because the recent wars have given the enough education to prepare ourselves. So luckily these wars have not happened in our geography. So we can learn from whatever has happened and see how do we collaborate in an effective way in the country to bring these technologies to such a stage that we can be, that it can be used properly for the defense of the country. There are core aerospace technologies, and with respect to transparent warfare, if I mention, first and the foremost being the platform for the remote sensing, be it a satellite in geostationary orbit or near Earth orbit, which ISRO has been doing for quite some time. Be it a high altitude pseudo satellite, people talked about it already. Government company as well as private companies are working on this. In fact, HL also is involved in some way on this. Be it an AVOX platform, which our country uses on Embraer with Netra system. It can be also UAVs, high altitude, long endurance UAVs, which everybody talks about, Global Hawk, MQ-9 Reaper, which have been around the globe, been doing the kind of surveillance, remote sensing, are the drones. Drones could be in the form of manned, unmanned teaming system, which one of our distinguished panelists spoke about. He was not happy with the term drone, so he said robos, we could call it. So better even if we call it robos, that will be okay, because anyway you're going to use them as robos. So they could be kamikaze type as sacrificial, or they could be recoverable type. We could use them for collecting the information, for remote sensing, or we could use them for combat. So both applications are there. Other than satellite, HL has been more or less been involved in most of these technologies. And the only one challenge which I would put before this distinguished community is the propulsion, power plant. Be it of any capacity, right from the small drone level power plant to the highest Su-30 or LCA Mark II or AMCA level platform power plant, which we would be needing in times to come. So whether it is powered by conventional means or it is powered by unconventional means, like what we say for high altitude pseudo satellite, where mostly solar energy is going to be used for long endurance at 60,000, 70,000 feet. So there is a need to recognize this need and invest. Because if we don't invest in this power plant technology, right from the electric engines for the smaller drones, which largely are imported today, and we know from where they are coming. So we have a lot of restriction, but still they are finding ways into our country. So unless we put our research and development in that direction, the range is too wide, and everything can be used in the transparent warfare. So propulsion being one of the major challenge, in my opinion, from industry perspective, because we are facing it day in and day out. Second major important element of any remote sensing or surveillance or reconnaissance equipment is the sensors. So sensors and imaging system. In today's world, whatever platform we are using in India, largely the sensors are imported. So, but it's not so that the capability does not exist within the country. The capability does exist, but the scales are not enough to make it a business case for the private industries to come up and set up the shop. So probably the government also need to look at this, how the sensors can be developed within the country. And let me tell you, the sensors need to be indigenous. If we are talking of a collaborative environment, a networked environment, if we are buying sensors from outside, integrating them is going to be a big, big challenge. And we have faced this. Because if you go to sensor manufacturer and ask them the interface control document you give us the information so that I integrate it with another sensor, so they will mostly not be complying with our requirement. So unless we have indigenous sensors, all kind of remote sensing independence, what we say, Atmanirbharta in remote sensing is not going to happen. So this is another challenge, sir, which I would request you to note, so that maybe in case if the society at the end of the conference prepares a document, so it can find a way in this. We talked about data mining, data analysis, artificial intelligence. So whatever future data we are going to generate, we can be sure that it could be in a structured fashion so that we can analyze them properly and base our decisions on those data sets. But at the same time, to generate the algorithm for decisions, it is very much essential that all previous data also should be structured and captured in a form so that we analyze them and try to build an algorithm for the decisions taken in past. And that is where the artificial intelligence comes into being. Artificial intelligence is a very, very collaborative terminology. And I was really happy to listen to presentations from Indian Navy, Indian Army, Indian Air Force, and the Coast Guard, that they've done a lot of work. But what is required to be understood, that this whole knowledge has to come together, to decide how your tool is going to predict the behavior of the enemy in a situation when you are in confrontation with him. I'll just illustrate, if you permit me, sir, from an Indian movie. I think you all would have seen Chak De India, right? I don't know whether you have seen or not seen. Definitely you would have seen. So the climax of the scene is the Indian women team was in shootout, penalty shootout. And the last penalty was to be shot. Shah Rukh Khan, the ostracized captain of Indian men's team, was the coach of this women's hockey team. He was under tension because that was the last match and final, and if you win, you win the World Cup. If you lose, he knows what is the price he has paid for the failure. So, if you all remember, when the Indian women player was going to shoot out, he was looking at the foot of the goalkeeper, whether the foot is placed such that she will move to the right or to the left, or she will not move. And he signaled to the player by looking at the foot that you shoot in that direction where she is not going to move. Now, this is an illustration. But this knowledge, Shah Rukh Khan would not have acquired in one day, right? Nobody would, observe to that extent that if you monitor the foot of the goalkeeper for the penalty shootout, you probably with 70%, 80% accuracy can tell whether you're going to hit the goal or you can't hit the goal. So artificial intelligence is like this. So very, very collaborative. And the kind of the knowledge base which our services will have, a programmer sitting remotely can never have. So this requires a very collaborative, very intense effort to write algorithm for artificial intelligence. Of course, based on whatever you write, the machine learning takes over and it updates itself. And mind you, in a war scenario, you should also know which country behaves in which way. Maybe Chinese will put the foot towards the right, but they really mean to go towards the left. This knowledge also we will not have. Because when we were in the B school, we were told, if you go to China and the Chinese will say like this, that means no. And if they say like this, that means yes. So this is contrary to what normally we see in our system. So artificial intelligence and data analytics is a very, very serious subject, and it's to be handled in such a way so that we get the correct output, which could be useful for us in a real wartime situation where we can't afford a miss. And the last technology about the navigational requirements. We have now a regional navigation, Indian regional navigation with higher accuracy, but probably in tomorrow's battlefield situation, that may not be adequate. So there is a need to enhance the coverage of our IRSS and see that this can get extended so that we don't land into a situation like we landed during Kargil war, that we asked for the data and Americans denied. So if we land in that kind of situation, we can never win a battlefield. So these were the technological intervention which in my opinion are very, very important. And now what we should do to keep ourselves abreast with the latest technology and develop a system so that in case of any provocation, we should be able to handle it properly. In my opinion, there are a few things that while we have to be updated on all these digital technologies with the end objective in focus, we should also develop certain technologies which are required to develop the deterrent. For example, hypersonic vehicle or hypersonic ammunitions, wherein because in such kind of battlefield situation, the speed is very, very important. So if you don't have the speed, you just can't win the war. So investment in hypersonic vehicles have already been done. DRDO is working a lot on this. So there is a need to expedite this. Another thing is, as I said, the speed is very, very important. So, and if we depend on the conventional means of computing, which we have been doing by now and which the whole world does, probably we will never be ahead of our competitors. So, what is more important is to get more results from quantum computing. And you all are aware that already there is a national consensus on this. Government of India is pushing a lot of research and development in quantum computing. So, but the time has come that we should be able to derive the applications faster. So, there are two things we get from quantum computing. One is the security, confidentiality, which the normal digital system does not offer. And second is the speed. So, both the things are important. And since the country has already taken a decision to go ahead, there is a need to expedite all this development. And third was directed energy weapons based on lasers or microwaves. Of course, there are ethical fallouts of this, but as a deterrent, investment in these technologies is very, very essential. Madam also talked about stealth material. In fact, I was really updated that now we are working on stealth with material probably which are going to be more environmental friendly. Right, ma'am? Yes. So, because so far stealth means composites. So, stealth is a combination of the aircraft structure design and the material. So, if you combine both, and normally in all the stealth aircraft of today's generation, we have composites in a great amount. And composites are one, disposing them off is going to be a very, very big issue. So, this is going to be creating a problem if we are not sensitive to this. I would also like to bring out one more issue, ma'am, for the noting by this distinguished committee. There are ethical and legal issues with transparent warfare. Since it has evolved so fast, nobody has thought about it. So, if our country probably, if it takes it in a proactive mode, maybe we can set up a legal framework for transparent warfare, and we can take care of privacy rules. Maybe India can become a leader to take this forward to the global platform and make an attempt to have a global understanding of what should be used and what should not be used, at least in peacetime, if not in wartime. And my last submission, madam, would be that there are many organizations in the country, research organizations, DRDO organizations are of course at the forefront, several IITs, IIT Kanpur, ISC Bangalore, Atomic Energy Commission, Center for Robotics, Center for Artificial Intelligence, all of them are working a lot of things in this connection, but there is a need to enhance collaboration with the targeted objective. Collaboration is one thing which we all spoke about. So, but the collaboration has to be with a targeted objective. Then only our dream of preparing our country for a big deterrence in the situation of the transparent warfare is going to happen. So, with these requests, I would conclude, and I would hope, sir, that the recommendation of this society probably would find certain things, very important things as a recommendation to the Government of India, so that these issues are taken up, and what Secretary of Defense Production said, that funding is very, very important. So, if we leave everything to the private company and expect that the private companies will fund from their pockets, it is not going to happen. So, we have to have a mechanism for funding of critical technology, for the technologies which require high investment, have got long gestation period. So, no private company, even the government companies also will not come unless they see a commercial interest in them. So, this is something which has to be done by the government. So, I hope probably this seminar would propagate this idea and make this country much more self-reliant in these technologies of future. Thank you very much, sir.
We can take some, if time permits, from the organizing team, we can take some comments or questions from the audience.
Okay,
Please, go ahead.
I'm Air Marshal Inderjit, fighter pilot. My question is to Madam Ray. You know, when we talk of stealth technology, the main problem that has occurred is it is spectrum specific generally, stealth. So the problem is that if you have a wideband radars coming up, then you are not clearly stealth. Now, whatever you metamaterials you have brought out, you talked about multispectral, but when we talk of wideband RF, I didn't really see, because whatever peaks and dips were there were specific frequencies. For our stealth to be effective, it has to be wideband spectrum. So what is being done about that?
So I agree that's usually a problem, and whenever you're making frequency selective surfaces, like the name suggests, you're going to have a tendency to select a particular frequency or a particular band of frequencies. So this is sort of, there are two ways to go about it. Again, a lot of the literature that exists in publications and that or research outputs that come out from the academic community, most of it is, let's say, because this is sensitive information, people will never give out the details or publish actual things which go into products, right? So one way of doing this, if you want a broadband response, is you could look at making random frequency selective surfaces. Okay, when I say random, it means you could randomize your features so that it doesn't select any one specific frequency, but rather selects a broadband thing, right? And so that's one direction that we also have been actively looking at. And we have seen this, that as you go more and more random in the structure, then you can actually broaden the peak, so to speak, right? The other thing is you can have this, again, multi-layered. When I say multi-layered, as in you can have two materials as part of your structure, one which gives you the broadband features and one which gives you, still those specific dips at certain frequencies that you may want. So, but it's a challenging problem, and I think when we do talk about multispectral stealth, the idea is that we do want to go wideband. When we say multispectral, we actually mean that rather than picking out a certain frequency, you want to go like a really wide range. So the results that I showed you was not from a frequency selective surface, so it was like a uniform coat that we made. And if you then remember the reflection loss that I showed you, that was relatively flat. Over the 8 to 12 gigahertz is the frequency range that we measured. Again, this was a lab scale thing that we made. But there, we actually didn't see any peaks, probably because you have a uniform thing. So you were actually not selecting any surface or any material. So the way we envision this is it has to be a two-pronged approach, where you either randomize and, extract all sort of frequencies from randomness, or you go for a two-tier solution where you have a uniform thing which dampens the whole of it, and then certain specific, frequency selection tendencies, which will dampen certain bands more. So.
Thank you.
Firstly, thanks for all the presentations. My question again is to Professor Ray and a comment for Commodore Maolankar. I'll talk about that later. Ma'am, very impressed by what you said. A lot of things I heard for the first time. Is there any structured manner in which you and your team are interacting with armed forces or Ministry of Defense or DRDO? If there's none, perhaps you have the chairperson right there. She should be able to help you. I think it's a very important area, but I'm not very sure if something structured is happening. And if it is not, it's a pity.
Yeah, so thank you for that question. It's actually the thing that we struggle with most, but we've had an interaction with MAM actually. We started with the help of Cmde, so this was a problem that, they helped us think about. And since then, we've actually reached out to DRDO and also to the naval forces to look at what kind of, so there's some level of interaction that's happened, but, we've not gone full steam ahead with things yet. So.
And I'm assuming there are others like you in the country, elsewhere in other IITs or Indian Institute of Science who are doing something similar.
Yeah.
I think that's excellent work. I mean, it's stayed completely unaware of all my 3 decades plus in the Navy. So thank you for that work. But a structured arrangement needs to be had. And are there any civil applications as well that you're looking at of this? Because that brings velocity to that kind of research.
All right. So we haven't really
There's nothing
thought
at all.
about-
I mean, I
No,
wonder
but-
who would need stealth in civil, but perhaps there is something that you should think
Well,
about.
so you do need a lot of it in, let's say for your cell phones, you know, you want to protect, there's a lot of gadgetry that's sort of now crammed into your cell phones, and a lot of the times they internally sort of interfere. So we know that the electronics industry does look at shielding per se, but of course not in the sense of microwave absorbing and all that, and their frequency bands are very different from, you know, what we've looked at.
All right, thanks. If I may make a comment and a suggestion to Commodore Maolankar. I've heard Commodore Maolankar you many times, and you make some very pertinent points. As a retired Navy officer, I agree with many of your thoughts that something lacks in the education of officers as they're sort of brought ready in leadership positions. I would recommend you should write them down in a structured manner and sort of pass it on to relevant people, because you don't have the right audience for thoughts such as these. These are important thoughts. Even if they see some opposition, it's still of value, I would think.
So my wife accompanies me whenever I'm invited to a college, any of the schools or colleges, and she's put a challenge to me that you'll never get invited a second time.
But you do get, right?
So not yet.
Just to add on to this, this is a project that Cmde has been doing for, I think, more than 2.5 years on stealth technologies and working with IIT Delhi on this. But when we started discussing this, it started off with a Faraday cage initially, you know, trying to look at shielding effectiveness and trying to see how EMI, EMC can be contained for aerospace applications. So that was the first idea. And from there, we moved on to the wings and how to reduce the signature. But when we are doing that, one of the ideas that came up was the simple mobile phone. And you know, there's so much of EMI, EMC happening there, and what kind of cages that have been put there to make sure that this shielding effectiveness increases. I think Professor Nirat has done some work on that. So there are plenty of civilian applications of the work that Professor Nirat is doing.
Any other comments or questions? Any of the panelists would like to make a comment? No. So then I'll take the task of concluding the session. We had a wonderful talk from General Inderjit on the challenges, technologies, limitations, how to overcome the limitations, how to enhance the situational awareness using the FPV drones. Thank you, sir. Commodore Maolankar, in his straight talk, talked about the need for collaboration, need for requirement engineering and systems engineering, and the couple of quick comments that came from Admiral Ahuja and Commodore Sujit shows both the problem as well as the way to approach it. The discussion that is happening, the leadership by Cmde in trying to identify the opportunities using ultrathin metamaterials for either cloaking or for making stealth. Ideally, if this happens within the organizations which are responsible for those things, that is the way to go. And that is where the collaboration should be happening. Unfortunately, it is happening outside the structured frameworks. So what we need is a structured framework for these collaborations to happen, to take forward these technical discussions. What is happening once a retired service officer or a technologist superannuates and then they're able to connect with the academic institutions or industries. Why can't this happen within the structured framework where people are in a position to state what the problem is, how to overcome it, and what is the way forward? This is my need. I need stealth in this form. I don't need a composite. Can you give me a structural material with which I can make a component using this technology? So if everyone sits down with their thinking caps on and try and work in a collaborative manner to overcome the challenges of today. So unfortunately, the jigsaw puzzle is one piece with each stakeholder. Till the stakeholders come together, we can't solve the puzzle. And this is something that until all stakeholders appreciate, and we have a framework process to make it happen. Within the government, nothing happens without a processed framework. So in addition to collaboration, today the need of the hour is to put a structured process framework in place which will not only enable but force the stakeholders to work on it. And if we can come out with that kind of a process, then I'm sure things will improve at a much better pace. Thank you, Professor Nirat, and I must compliment SAMDES for taking this initiative of working on a technology challenge and kind of trying to see how to make things forward. Professor Sajal Prakash, in addition to talking about the need for collaboration, brought out the imperative need for working on indigenous sensors, navigation technologies, our own propulsion systems, and the use of indigenous algorithms, which are the need of the day, if we have to be independent, if we are not looking at any malwares, backdoors, in the solutions that we want, then we must have complete technology basket from the indigenous domain, and it is possible. He also talked about the need for developing hypersonic systems, quantum technologies, directed energy weapons, and also highlighted the need to look at ethical and legal issues in using such systems. So overall, I would like to thank all my co-panelists, wonderful discussions, and I think I'm very happy with this discussion. For once, we had a very, very focused and targeted discussion, which was very, very meaningful, and thank you all, and to the audience. Thank you.
Thank you, dear panel members, for that stimulating discussion to recognize their invaluable contribution to the field of defense and technology. We invite General Lamba, former Chairman, we invite Dr. General Lamba to kindly be at the stage and felicitate the speakers.
Wonderful session.
To Dr. Chandrika Kaushik. To Lieutenant General Inderjit Singh. To Commodore Jaideep Maolankar. To Shri Sajal Prakash. To Professor Nirat. May I please request for a group photograph, please? Sir. Thank you, dear panel members. We're truly grateful for the insightful contribution. It has been a great honor having you all here.